Hello everyone and welcome to Module 2. Since this is a course on quantum computing, you'll have to have at least some understanding of classical computing. And so in this module, I'll introduce briefly classical computing. In particular, we'll discuss some basic concepts of classical computation like bits and logic gates. So what is computation? Well, when we think of computation, we generally associate it with numbers. So we think of some long calculation that involves arithmetic operations, for example, addition, multiplication, subtraction. And historically, doing these operations is what motivated people to invent computing devices. However, these primitive motives later inspired and became part of a much richer theory of computation. More generally, a computation is described by what is known as an algorithm. And an algorithm is just like a recipe. It is the description of a sequence of logical rules to be applied to the input to a problem, for example, two numbers, in order to arrive at a desired result, for example, the sum of the two numbers. Now, Alan Turing is considered to be one of the founding figures of computer science, of classical computing. He taught a lot about what it means to do computation. He came up with a detailed physical model for a machine that abstracted the salient features of the process of computation. So this model for a machine is known as a Turing machine, and it can implement any arbitrary algorithm. So in this module, we won't describe Turing machines. Instead, we will focus on what is an essentially equivalent module of computation, which is closer to what is used in modern-day computer architecture. So these are based on digital logic circuits. And so this model is known as the circuit model of computation. And we'll discuss the circuit model of computation through two key concepts, the concept of a bit and the concept of a logic gate.